طيب. بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله. السلام عليكم ورحمة الله وبركاته. First of all, I want to thank everyone for coming to this webinar. I would like to thank the College of Computer Science and Information System in Najran University for arranging this event for students, researchers, and whoever might be interested in technology topics. I also want to congratulate Dr. Bakri Awaji for completing his PhD. Dr. Bakri has received his master's degree in computer science from the University of Colorado, Denver, from the US in 2015. Dr. Bakri has received his PhD degree in computer science from Newcastle University from the UK in 2022. Dr. Bakri's main interests are in blockchain technology and decentralized systems. Today, Dr. Bakri, inshallah, will talk to us this afternoon about his PhD work, which is titled The Adaptation of Blockchain Technology for Developing a Trusted Achievement Record System in Higher Education. Thank you again, Dr. Bakri, for willing to share with us your work. The mic is yours. Whenever you are ready, you can start.
Assalamu alaikum wa rahmatullahi wa barakatuh jami'an. I would like to start with thanks Dr. Yusuf for introducing me to the team here, and it's my pleasure to present my work that I have done during my studies for PhD degree. And today the talk is about the studies and the work I have done to achieve the PhD, and my dissertation was under the title, The Adoption of Blockchain Technology for Developing a Trusted Achievement Record System in Higher Education. So before starting talking about the dissertation itself, so I just give a brief description. Why did I choose to work on blockchain technology and also to work with the education system as well? So mainly I was looking to find a topic or the dissertation that could be applied and capable to be applied in future in Saudi Arabia and the university. So then I tried to generalize the idea to make it applicable to be applied in everywhere and every university around the world. So this model have been implemented and it is globalized and could be applied in the education system and also in any similar system that needs like a trusted environment to validate and authenticate records. So mainly, so we can see we are applying blockchain technology to build decentralized application or systems or these distributed systems for different purposes, but the use cases in this research is the achievement record system for students in the higher education. And the outline that I'm going to talk about in this presentation, I will start at the beginning to talk about the motivation itself, the gaps that we have found in the educational systems in different countries, and how did we use the new technologies to address these gaps and came up with the new solutions that would be benefits from different universities around the world. So then we'll talk about the exact aim and the objectives that we are aimed to achieve during these studies. After that, I will talk about the blockchain in some details, actually, to make it possible to everyone to understand exactly what the system structure, which is the structure of our proposed solutions. Then we'll go through the evaluation and the results that we got from these studies, and finally, I will summarize the contributions of my dissertation. And at the end, I will present some publications and awarded achieved from presenting this work to the scientific committee. So basically, the problem statement here, or what exactly we are going to address in the educational system, At the beginning, before finding the gaps, we were looking for, we did like a study to address or investigate what exactly the issues and the problems within the educational systems in every educational system in different countries. Basically, each country adopting different model of educational system, especially in the higher education, and each country actually suffering from different issues and problems with their educational systems. The majority of the countries or the educational systems in the universities among the world are suffering from the validating and authenticating certificates or achievement records for the students. So the problem exactly was they are suffering from the fraud and the manipulating of the degree or the activities that the students are doing during their life in the university. So basically, we're gonna just summarize the problems in two main points. The first point was the lack in the process of recording the achievement record of the systems of the students. So just to make it clear, the achievement record system, the achievement record is something different than the academic record, which is called the transcript, the official transcript that students received after finishing their studies in the universities. So what we mean with the concept, the achievement record, is the record that contain every activities that students done during their life in the university. For example, if they have done some voluntarily work or hours and they achieved a certificate for that work. If they got, if they did some presentation or arranged some meetings or they did some demonstrating for some modules. If they have some publications or present some workshop or did some exact academic work that not related to their modules. So all these activities are not recorded in their achievement and their transcript at the final. So this is the first point. This is the first point and problem. The other problem is if the students build their CV by their own and add those activities certificates to the CV, which is normally done by everyone. So in this case, the potential employer in the future will have a different issue which is related to the validating of this document. So how could the employer guarantee what the students provide is correct or not have any fraud issue? So this the main 2 points were found in every educational higher educational system in each university around the world. So from this point, we moved forward to find a solution from the technical part as a computer scientist to address and cover these problems and provide a good solution and very trusted solution for stockholders, university, and the students as well. So our aim from this, the aim of this research was to use the blockchain and smart contract to provide or to build a trusted achievement record that enhance the trust and privacy and security at the same time. So the objectives was to help the student to record every single activities they done during their life in the university and authenticate original key documents and trusted document through the system for the students. The other thing is to provide a proof of their skills. So once the students done any work during their life, that means they have earned some skills that are not related to the academia. So to prove this system will help them to provide a proof for the stockholders or for the potential employer in the future that tell them we have different skills that are not earned from the academia, but we got them from different resources. The objective is to encourage the students in the higher education to learn more and to improve their skills beside of their learning in their academia section. And finally, to help them to build their future plan of learning, and also to help the stakeholders or the employer in the future to find the most appropriate graduate students from the system to their jobs. So from that point, the idea of this research customized and finalized, as we can see in this figure. So we aim to build a system. The system adopted a blockchain and smart contract in the back end, and a decentralized application or distributed application on the front to facilitate the communication between students, universities, and this employer in the future. So from this point, to understand exactly how did we build our solution, it's gonna be better to start from explaining what's exactly the blockchain now and how did we use the blockchain in our solution. So from this slide and the next 3 or 4 slides, I'm just going to explain the technology itself. Then we will link this technology and the concepts to our proposed solution and to the finally to the gaps to get the whole image about our solution. So first, the blockchain. In this slide, I will give the definition, the structure of the blockchain, the layers, the platforms, and also the types. So blockchain is not so old innovation. It's very new innovations, and the usage of blockchain it's increasing by the future and by the time for different purposes and for different from different sections as well. To know what's exactly the blockchain, we can define the blockchain in different ways actually. So for each feature of a blockchain can give us a definition. For example, we can define a blockchain as a distributed database because we have a distributed ledger on the blockchain, and this ledger is saved in each node, and each node can see the content of this ledger, and this ledger is updated. So it's like a database, but it is distributed database. So this is a correct definition. We can also define the blockchain based on the network structure. So we can say the blockchain is a peer-to-peer network that facilitate and connect nodes, facilitate communicating between nodes in the network, because it's connect the node, each node to all the nodes in the networks. So this is also a good and fine definition for the blockchain. We can combine these two definitions together to get a big image or big definition for blockchain. So we can say it is a peer-to-peer network that store data on a ledger which is distributed on the block on the network. So every definition is correct, and every definition is presenting a different feature of a blockchain itself. So let's move to talk about the layers of the structure of the blockchain to know exactly what's the blockchain and how does it work. The blockchain infrastructure contains, in general, there is a debate actually. Some scientists said it contains 4 layers, and some said it's 6, and so on. Depends on the categories and classification of the tools and component with each definition or each scientist. So, but the majority are agreed that the blockchain contain of 5 layers. The first layer is the infrastructure layer, which is the infrastructure where the nodes are connected with each other to share the data. So we can say it is basically the network layer. And the other layer, which is the data layer, which is responsible to link the data through the hash between blocks on the blockchain. And we will talk about this in the next slides to know exactly how the block added to the blockchain and how to validate and add the transaction to the ledger as well. The third layer, which is the network layer is responsible to present the peer-to-peer properties and characteristics of the network itself. And the third layer, which is the consensus layer, and which is the most important layer in the blockchain infrastructure. So and this layer is responsible to validate and authenticate transactions, and also we can say the miner work well done in this layer. Mining, that's mean validating, authenticating the transaction at the beginning, and then validating this transaction and add this transaction to the block, and finally add the block to the blockchain, which creating the ledger at the end. And finally, the application or presentation layer. And this layer is responsible to present the functionalities of the blockchain for to the end user. So the end user will directly deal or actively deal with this layer directly in order to communicate with the different layer, the other different layer in the blockchain itself. In the application and the presentation layer, we can see here, we can build the decentralized or apps to do whatever we need to do with the blockchain in the back end. In our solution, actually, we deal with every single layer differently, and we also build the decentralized application at the front end in order to represent the functionalities that we need to execute on top of the blockchain, and to get the benefit of the blockchain features. So to summarize the blockchain features, we can have like a big idea from this list. So the blockchain itself has so appealing features that make this technology or this innovation very attractive for developers, either to work with in the technical part to improve the technology itself, or to build solution based on this technology in the future. So the blockchain features that makes it very attractive are the decentralization, which means we don't have to have a third trusted party to control the communication between the nodes in our network. It is trustless environment with no central authority. Trustless, that means we don't have to use anyone in between the users to control the communication between them. So they can communicate with each other with no need to know each one. The only thing that we need to know is the address for each node in the blockchain. So which build a trust between the users on the blockchain network. Blockchain is secured by design. Secured is related to the consensus algorithm like proof of stake and proof of work, which were designed to be more secure and to add the data to the data sent in the transaction to the blocks in security manner, and to prevent any possible way for fraud or manipulating with the data on the blockchain. One of good and bad features of the blockchain is the immutability. Immutability means anything stored or added to the ledger on the blockchain cannot be changed or edited or removed anyway. So it is immutable and cannot be changed at all, even by the data owner or by the user who sent the transaction to the blockchain. The other feature is the transparency. So the transparency means that each node in the blockchain can see the transaction and can track the transaction record in the ledger, because each node will have like a copy of the ledger on the blockchain. So everything is visible for anyone in the, on the blockchain. This feature is also good and bad at the same time. It's best, and we for some solutions, they have to do something exactly to avoid the problem that could happen because of the immutability and transparency. And in our solution, actually, in my solution, I have faced a lot of not limitation, but we can say challenges regarding to the immutability and transparency of the blockchain. The auditability, auditability, that's mean to validate the block or transaction in the blockchain, it's not just one node decision. So the majority of miners have to agree and validate the transaction. So that make this the network very secured and very trusted at the same time. So beside of just get the decision from just one node to validate, authenticate and validate the transaction, and then add the block to the ledger or to the blockchain. So we have the consensus algorithm that take the work to authenticate and validate the block based on the auditability. So the majority need to agree of the authentication and validating the decision of authentication and validating the transaction and adding the block to the blockchain. Finally, the smart contract. So this is one of the most important and good features of the blockchain itself. So smart contract is a concept, or we can say it's a technology that's self-executed program that can be run on the top of blockchain. It's called smart contract because there is no need for the human to execute or deploy the smart contract every time on the blockchain. It's self-executed. Once the smart contract deployed on the blockchain, so then it will keep running all the time, and the network status will be active all the time. So then the network will never get down, and also the smart contract will never stop working. It will be directly executed for the whole time. So this is a smart contract. It gives us like a key to do so many works with the blockchain and to monitor how to use the blockchain in the back end, and to monitor also what exactly the function that we need to use to execute on the blockchain or off a chain on the front end. So basically, this feature make the blockchain very attractive for everyone, every developer who are looking to deploy or develop a solution that provide trust and security, and also remove the centralization from the proposed system. To make it more clear, we will give here an example. So the figure in the left. So this model built on centralized technology, which means there is a single authority in between the users, and this single authority, there's no the other users have no choice. They have to trust this authority, and this authority will have the ledger, only one ledger, to add the transaction and to monitor the communication between the nodes in the network. The good example in here is we can consider the nodes as the bank customers, and the authority is the bank itself. So once any node in this model needs to send transaction or send money to the other node, that means the bank need to first authenticate this transaction and check in this ledger if the sender has enough of money to be sent. And then if that's correct, then to validate the transaction and send the money to the other party. So this process is gonna take a while, take time, and also we will have two main issues, which are the trust and also the centralization. So if any problem happens with the trusted authority, for example, the single point of failure, so that means every node will disconnected with the other nodes of the network. While instead in the network, the blockchain or the peer-to-peer network, in the right figure, we can see each node in this model will connect it to all the other nodes in the network. And also there's no like a third party or trusted party between the nodes to communicate, to facilitate the communication between them. So every node can communicate directly with the other node. Each node don't have to know who is the other node. They only need the address of the other node so to send a transaction. Each node in this model will have the ledger. It is exactly the same ledger with each node. It's updated, and every transaction in the between nodes in this network will be added automatically to the ledger, so it is visible and immutable. So in this case, we can say this model is more trusted, and also this model is will never the system in here will never down, and also we can see it is more in the performance. The performance in this model is more better than the centralized model. So from the explanation, I just summarized the 3 main points. The blockchain can be used to develop or to come up with a solution to provide trust and to avoid the centralization problem, and also to provide more security environment for the solution. Okay, so from this point, I will move to talk about our my system structure and my system, my proposed system actually structure. So in this system, the back end of the system is the blockchain itself. In the blockchain, we have different nodes, and the different nodes in here could representing different users of the system. For example, users could be at a node in the blockchain university. Any authenticated person from universities could be a node, and also any potential employer could be a node in the blockchain itself. In the backend, we also have the data storage, which is a concept. So every node, not the node exactly, a smart contract. Before talking about data storage, let's explain the smart contract on the nodes so we can know exactly what I mean of the data storage, the blockchain. So we have also smart contract running on one node on the blockchain. So the smart contract, in this smart contract, we have deployed, implemented many functions that necessarily to be executed only on the blockchain, and then present the work of this, the outcome of this functions by the front end of our system. So we have the smart contract. In smart contract, we have many functions designed to do specific work with our solution. For example, to register parties to the blockchain. So only the registered parties on our blockchain can send transaction between each other, because with the blockchain, we use a public blockchain, and we're going to talk about the type of blockchain later. So public blockchain, that means it's a blockchain contains so many nodes from different parts on the world. So, and we don't need every node in this network to send transaction to our system. So to do that, we have to run and to deploy a smart contract on one node on the public blockchain. So this smart contract will allow only registered users to send a transaction to our using our system. That to ensure we just have specific nodes, authenticated nodes, that can be deal with our solution or with our system. So that we in our smart contract, we have function to register users, we have function to register to sign and match the certificates to some users and universities. We have functions to monitor authenticating the certificates by the universities and send the hashes and secure data to the blockchain and so on. So that's why we need the data storage on the blockchain. Data storage in the blockchain, it's not like a database. It is every smart contract has like a small data storage that could be used as a database for the smart contract itself to run and execute or exactly to do some work with the functions on the smart contract itself on the blockchain. And also we have a consensus algorithm in this, since we have used the public blockchain. So with the consensus algorithm here is a proof of work. And previously, the network moved forward to use the proof of stake instead of proof of work as a consensus algorithm, which is better actually. And finally, a ledger, which is a document that contains every single transaction sent by the system or in the network. So the nodes will have this copy of this transaction. So on the front end, we built a decentralized application. This decentralized applications have different purposes, actually. One of them to manage exactly the users of the system. So to manage how to register the users, how to register universities, and to register the potential employer, and also to do some different mechanism. For example, authenticating certificate, how to secure the encrypting and how to secure the certificate before sending them to the blockchain, and also how to deal with the different digital wallets of users to allow them to send transaction to the blockchain. So since we have blockchain and users, so the users need to have digital wallet to be able to send transaction to the blockchain. So we will have like different mechanisms to deal with the digital wallet. And we also have like the transaction manager tool or component that link the smart contract to the front end of our system to facilitate the communication between the front end and the back end, and also to allow the front end of the system to present the functionalities of a smart contract on the blockchain itself. So in the front end, we have applied so many different mechanisms. We have so many different scenarios, and also we have too many components and tools adopted and implemented in the front end as well. For example, we have used the identifying and access management component and tools. The aim of using this component or implementing this component to facilitate or to control and monitoring the registration process of the users to the system. And also we have the digital wallets, as I explained before, to control the transactions by the users to the blockchain. And also we have the transaction manager to facilitate the transactions between the user, the digital wallet of the users, and the smart contract on the blockchain. We have a database as well, and we have used the SHA-256 algorithm to encrypt the data before sending them to the blockchain. So let's just talk about the SHA-256 and 56 that we have used, and why did we add this algorithm in the front end. So as I mentioned in the blockchain features before, one of the problem of the blockchain is the audibility. So everyone in the blockchain can see the transactions and the details of the transaction. The content of every transaction is added to the ledger, which means every node in the blockchain can see the transaction and also can track all transaction in the ledger. And we are dealing with the student sensitive data, which means we are dealing with the certificate and also the university's informations and also the employer information as well. So we cannot save this data or this information directly to the blockchain. In order to solve this problem or this challenge, we had to encrypt the data before sending them to the blockchain. So that's why we have like application logic in here to apply some mechanism and also to monitor the data flow from the front end and to encrypt the data using the SHA-256 and then send the transaction with the encrypted data to the blockchain. In this way, no one in the blockchain can know what exactly the content of the transaction, but the users of the system can encrypt the data and can see the original document that sent by the university to the system and validated on the blockchain and authenticated and added to the ledger on the blockchain. So there are so many details actually in this system. I cannot actually go through every single details, but this is the general view of the front end and the back end. This system is deployed actually or designed to be friendly use, and it was one of our objectives to make the system very easy to be used, especially for the students. And we kept in our mind that the students, not all the students or the users in general, will have a good background about the blockchain and sending transactions to the blockchain. So in order to solve this challenge, we designed our solution to be very friendly, and we did different investigation to identify what exactly the component and tools and mechanism that the most appropriate to build system, and users, the end user can use it simply and easily with no problem, and to avoid any complexity of using the complexity of a blockchain infrastructure itself. So this system has been implemented and presented for the end users and used by the end users. Sorry. In a very easy and simple manner. We will go through the design and give some example of the scenarios to give more idea about how easy was the design conducted to use to help students and the users to use the system. From here, we can see the homepage of the system. As we can see, the design is very basic and very simple, and we aim to make the design of the system something like the users used to see every time they use the computer. So it's basically looks like login to any system in the normal using of the computer. Also, the registration to the system. In the back end, the registration is very complicated because we are registering the users to the front end and also registering the users to the back end and creating digital wallets for some type of users, for example, the universities and employers, to allow them to send transaction. So we aim to build the system, design the system to make it very easy and to have the users not noticing that they are using the blockchain in the back end. So this was one of our aim and objective in this system. So I will give some example of scenarios so we can see how the users can log in and use the system in the real world. So here is the admin of the the system admin dashboard, and here from this dashboard he can register and control the users of the system. And for example, adding a new university and then register the university to the blockchain. Once the university registered, we'll have the name of the university and the address of the university, the digital wallet created for the university, and the blockchain hash, which mean the transaction sent to add the university to the smart contract, and the new block added to the blockchain. So from here, also here, we can, the admin can edit or delete the information of this university, edit necessarily in the future. And after the student registered in the university, in the system, the admin can see all the registered students from here, and also can manage their account from this port. And here's an example of the university scenario. For example, from once the university registered by the system admin, and registered on the front end and back end, the university will be able to add students to its list. We need to mention one thing. The university will not be able to register the student by itself, but the students can register to the system by their own, and we have a reason for that. So the reason is that if we make the university register their students, that means we will have a problem in the future if the students move to another university or if the students finish his studying at this university. So that means if he finished or moved, that means this university or the value of the system will be end at this point. So to make this system valuable and generalize the idea and make this solution applicable and applied for any level of studying or education system. So the best scenario is to make students register by himself. Then once he registered and his name in the list of the database of the system, then any university or educational institution, the students attend, they can authenticate certificate for this student. So they just need to add the student from the database to their list and then authenticate the certificate. How could this help the student? This will help the students in the future when they just get or earn more certificate from different universities or different educational institutions. For example, if a student starts studying at Najran University, so then he registered to the system, Najran University is registered by the admin, the Najran University can add this student to their list and authenticate certificates for any work. Once these students move to another university, for example, doing a master's degree in different university, so the new university can just add this student to their list and authenticate certificate and so on. So in this case, we will have no limit to use the system either for the student and also for the educational institutions. So that's why we don't allow the university to register the students. It's more better to let the students register to the system, then the university can add the student to their list and authenticate certificate for them. From here, the university can upload the certificate for their students. So here we have this, for example, this university can add the student from the list, from the database, and then fill all this field and upload the document or certificate. Once they're done, the students can, from here, they can add student to their list. So from this list presenting all the students in the database. So then when they select the student and submit, and then the student will be added to their list. Once the student is added, then the university can upload document or upload certificate for this student. So from the first field, they can have a list of the added student to their list. And then once they just select the student, they can add the name of the certificate and choose the file or certificate and upload this document or certificate for the student. And once they submit, submit or upload the certificate, the student will automatically receive an email to inform him that the university authenticate a certificate, and this certificate is added to his account, and this is on the system directly. So let's talk about the student scenario now. So students can register from this from the homepage of the system. Here is the registration form, very basic and easy. And once he's registered, he will this is an example of one of the registered students to the system. So the dashboard here, he can see like a summary of the degrees or certificate uploaded to his achievement record. For example, this student has one university degree, 0 transcript. He has 1 letter, 1 poster, programming certificate, and attended 2 workshops. To know more details about the details in here, so from the document list, he can see the every details about every certificate he achieved and received. And also he can see the blockchain address for the certificate, and also the document hash, which means the transaction of the transaction, the hash of that links the transaction to the block on the blockchain. And he can also see the copy of the certificate and can print it out. With the other thing, the students can share any document in his achievement record just simply by selecting share from the list in the right. And once he selects the share, he just need to put the email address of this the receiver or the one who would like to share the certificate with. So once he,
Dr. Bakri, we will have just 5 more minutes, and then we will have a
sure. So just I'm gonna move forward to the evaluation method to evaluate our proposed solution. We have some different studies conducted. We conducted the system usability test and also the end user computer satisfaction test. We designed 4 different questionnaires to measure the satisfaction of the students and universities and employer of the system. And also we did the performance evaluation to evaluate the confirmation time and the cost of our proposed solution. To do that, we have designed an experiment and sent invitation. 5 universities participate in this evaluation process. One of them is Najran University, 2 of them from UK and 1 from the USA. And that basically the results, we got very good results regarding to the usability of the system. So we got the degree 77.1 in the system usability score, which is representing the good. And also we got very good results regarding to the satisfaction of the users of the system. Either the universities from the universities, students, and also the employer or stakeholders. And also here we have evaluated different objectives that related to the main objective of this research. We got very nice results representing this figure. And here is the result representing the performance of our system comparing to the other solutions that similar to our proposed solution. The results we got are good results and give the advantage over the current solutions in the market. Finally, the contributions of this proposed in my dissertation of my thesis was summarized in 9 different studies listed in here. And here is the list of publications that we have published in the very well-known conferences, journals relevant to this project actually. So we also have something submitted, some papers submitted to different journals, and it is under review for now. And this work has received many different awards. For example, we got I have received the best presentation in 2 conferences. The paper, I received a best paper in 1 conference and invitation to be a chapter book in Springers. And also I got an invitation to present to publish the whole work in the Wiley journal, and it has been submitted and it is under review for now. So this is the all for tonight. I know it's very brief this explanation, if someone get interested about what the work and would like to know what exactly the future work, I will be very happy to communicate with him via the email or personally or phone, the phone. Thank you very much for attending my talk. Thank you very much for listening, and I'm happy to receive any question.
Thank you so much, Dr. Bakri. That was really interesting topic and a very informative talk. So we really appreciate your effort to present your work, and congratulations again in completing your PhD. We are happy that you are rejoining us in the college. So
thank you very much. My pleasure.
Now we will open a session for questions and answers from you, Dr. Bakri. So if you have any questions, please raise your hand, and I will try to open the mic and mute you. So. Okay, any questions?
السلام عليكم.
السلام ورحمة الله وبركاته. حياك الله دكتور.
حياكم الله جميعا. دكتور بكري.
حياك الله حبيبي.
السلام ورحمة الله.
السلام ورحمة الله. حياك الله.
Congratulations for your يعني a great achievement يعني of your PhD. والله we are so proud of you يعني, and we are so happy to have you إن شاء الله in our college, and I wish you all the best إن شاء الله بإذن الله.
Oh, thanks a lot, Dr. Muhammad. It's my pleasure actually to hear you today. Thank you very much for attending my presentation, and I hope it was like that half presentation.
No, I think يعني I believe this is one of the nice presentation and good presentation that I ever heard يعني والله.
Thank you.
I think the topic is new, and the details and information that we got يعني in this presentation, I think يعني so informative يعني to us. Just I have one question, Dr. Bakri.
Yes, please.
Yeah, I think the blockchains system that you presented يعني looks like يعني the peer-to-peer system. That's what I understood يعني. This is my I think view or my information about the blockchain. I think it looks like the peer-to-peer, and there is one slide and you talk about the SHA 2050 or something, and I just want my questions is there any needs to secure the transactions in the blockchain system, as I understood the system looks like the peer-to-peers. Is there any needs to the security term or to secure the transaction inside the system, or the model or the system can secure itself?
Thank you for your question. It's a very nice question. Good. I can answer this question in two different parts. The first part regarding to the peer-to-peer network. So the blockchain itself, it's based on the peer-to-peer network infrastructure. So it is peer-to-peer infrastructure, and the nodes can communicate to each other directly. Regarding to the encrypting of data before sending them to the blockchain, as I mentioned before, blockchain is secured by itself, but the problem is the blockchain is immutable and visible. So which mean every content of the of any transaction will be added to, after validating, will be added to the transaction list. We can call it a ledger, and added to the blockchain. So any node in the peer-to-peer network will be able to see the transaction, the content of the transaction, and also to track the transactions in this ledger. So since we are in our system, we are dealing with some sensitive data. So we are dealing with the private. We have privacy issue. If we send the metadata of the university and students and the certificate directly to the blockchain, so anyone in any node in the blockchain can see the details of this transaction, that the content of the transaction. For example, the issuer of the certificates, the address of the certificates, and also the details of the receiver and the content of the certificate itself. So, and this is a big big issue regarding to the privacy of the sensitive data of the students. So to avoid this problem, we had to encrypt the data before sending them to the blockchain itself. So that's why we need to use the SHA-260 and 56 on the front end to encrypt all the mentioned data, and then create a transaction. And the content of this transaction is encrypted, corrupted data only, which is exactly the hash for the corrupted data. So then we send a transaction that contains the sender address, the receiver address, the content, which is the hash for the corrupted for the certificate, and the issuer and the receiver as a transaction. So then any node in the blockchain, we will see a transaction contain a hash. That hash will present nothing to them. The only users of our system can encrypt this hash to see the original document and to know who is the issuer and the receiver of the data. So this is the mechanism we use to provide more privacy and to add more security to our system. Yes, of course, blockchain is very secured, but it is secured in terms of the blockchain itself. So blockchain cannot be hacked. The blockchain the miners will not validate any transaction. There's many regulations and also specific algorithm need to be run on top of blockchain in order to validate the transaction. So this is correct. The blockchain is secured by itself as a design, but regarding to our solution, we need to provide different type of security for our users and also for the data sent through our solution.
Perfect. Thank you so much, Dr. Bakri.
Yeah,
if you have any other questions from the audience?
Jazakallah khair, if I can. Thank you, Dr. Bakri, for your great achievement and for this informative presentation. And I really enjoyed this topic. I have one question regarding the point you mentioned during, which is you are encrypting the data before send it to the block or to the chain. Did you measure the overhead of the with the encryption and without the encryption? And does it affect really the surface? Like, is there an overhead when you are encrypting the data and send it to the block or not?
Thank you very much for your question. It's a very good question, actually. To be honest, this is out of the scope of our research, but it is one of the limitations of the proposed solution. The reason is in this, as in our the data flow in this system, in our proposed solution, contain storing data on the front end. So, of course, this will affect the performance of the decentralized application, this in the front end, and will cause the overhead absolutely. But it is not measured because it's out of the scope, but we are looking in the future work to solve these challenges, this problem, by using the IPFS cloud service. So then we will not have to do this step at all. We can use the hash sent from the IPFS to the front end directly. So in this case, we will have no overhead in our system, and also we can solve the the performance of the front end of this solution, and also make our application heavier, not heavy. So how can very light and easy to use, and improve the performance of our solution at all.
Thank you so much, Dr. Bakri. Thank you, Dr. Hani, for your question. Any other questions, please? And we'll just make it very brief from the question and also from the answer, please. Just we can have more questions than answers.
Assalamu alaikum.
Alaikum salam wa rahmatullahi wa barakatuh.
تفضل دكتور حمد.
Thank you, Dr. Bakri. Thank you, Dr. Bakri, for presenting your wonderful research work. Just I have a quick question. Usually when we talk about distributed and synchronous and distributed system or decentralized systems, we have to make sure these systems are synchronized and also fault tolerant. So what do you think usually the schemes or the techniques they usually to make sure that just to avoid any synchronization or any fault in such systems, because it is distributed systems?
I really don't quite get your point. So if you can just clarify what you mean of.
Yeah, I mean, if you have a failure point in the blockchain, so how usually, what techniques usually, or maybe how usually they manage this failure in our network, on the network system?
Oh, okay, got your point. Thank you very much. Yeah. To answer the question, I will go back a step back to the feature of the blockchain itself. So as I mentioned, the blockchain system or network never be shut down. So it's running, the status of the blockchain is always active. So there is no worry about any problems that occurred because of the system shutdown. And also regarding to integrating the blockchain to the decentralized application, this could be easily done using the Web3 and connect the functionalities on the smart contract to the front end using the APIs. And then that make the communication between the back end of the blockchain smart contract as well, the network, peer-to-peer network, to the front end decentralized application done easily and very fast. So we have no actually concerns regarding to this point.
That's perfect. Perfect. Thank you so much, Dr. Bakri.
Thanks a lot.
Any other questions, please? Okay, I have a quick questions before.
Yeah, please.
Another question after that, if we have any. So it's I will take the direction to another area. I know some questions were very technical.
Yeah, please take it.
Yeah, I want to ask about how do you see the infrastructures that we have in Saudi universities? I know that you have worked with some of those universities. How do you see the infrastructure for those universities and how this is really aligned with the digital transformation that you are seeing in Saudi Arabia? So I want to see from your expertise in this area, how do you see that? Are we ready? How can we really use the techniques that you are developing?
Oh, thank you for this good question. Actually, from my own perspective, I can see that the infrastructure, the education infrastructure in Saudi Arabia, and in particular the higher education infrastructure in Saudi Arabia, is developed very quickly and rapidly, and they are moving forward to the e-government so quickly. They are applying so many software solutions, and move from the regular paperwork to the e-government, which simplify the communication between parties in this environment, and also to increase the performance and throughput of the system at all. So what I can see, it is we are very ready actually to move forward to the next stage. And I think it is every university has the ability to present some works in this matter. So for example, we can suggest in Najran University, we can just move forward and make the authentication of the certificates using the blockchain as well. So why not? So it's applied in some universities, as I see, but it's not the idea is not applied for all, but we can get the advantage of this idea and apply it in our environment, local environment, and then we can generalize our outcome with the other universities. So backing to your question, so what I can see, we are very knowledgeable and very well educated, and we can move forward from this stage to the next stage directly and very fast. And I think the government are supporting any movement in this matter.
That's perfect. Thank you so much, Dr. Bakri. We will have the last question here because, as we always say, we don't want this to be another PhD defense for you, Dr. Bakri.
No, I really enjoying actually the thoughts and the questions, because it opens new horizontals, even for me, for the development in the future and for the future work as well.
Thank you so much. And your talk is really interesting and your topic, and that's why we're having so many questions here.
It's my pleasure.
Go ahead, Ms. Saad.
Assalamu alaikum.
Assalamu alaikum.
Thank you, Dr. Bakri, about nice presentation and very important technology for life. My question, this your technology, maybe not, you have some channel not implemented because the block checking, it is modern technology, but no, some people know it is not know about this technology and how to implement it. And also for block checking, for example, for student, you can upload anything like document. If you have any feature to protect the, for example, copyright for protection or like this one, or any features.
Thank you very much for your question. As I understood from your question, so you have two parts. The first one regarding to the blockchain technology and innovation. So you are asking that it is a new technology, new innovation. So there is a limitation of knowledge for the users and how to deal with this, the complexity of the new structure. And the other part, which is regarding to the copyright of the authenticated certificate or document you upload it to the system, and why the students cannot upload the certificate by their own. Okay. For the first part, which is regarding to the blockchain background, so I really agree with you. There is a very limited, there is a big limitation regarding to the knowledge of the people or the background of people regarding to the new technology. So that's why in my solution or my system, that's I did different studies to make our this solution very easy to be used and very friendly for users, so they don't feel there are a blockchain in the back end. So this limitation can be actually adjusted and can be solved by the developers themselves. So they can do some specific work, apply some specific scenarios and mechanism to avoid the complexity of using the blockchains. And this is exactly what I have done in this project. And regarding to the second part, which is why the copyright and the copyright of the document. So this solution is very trusted environment. So any authenticated certificate uploaded through the university, it is actually copyrighted, provided. So no one can do anything with this certificate. The reason is this the uploaded document will be corrupted at the beginning. So we will keep the originality of the document. So no one can change anything in this document before sending them to the blockchain. Once we send them to the blockchain, that means this document has been registered to the issuer, and no other issuer can authenticate the same certificate, the exact same certificate for this student, which means we save the copyright for of the document for this issuer. So this problem is automatically solved by the system. The third part, why the students cannot upload the document by their own. So it is impossible or not allowed for the student to upload any document in the system actually. That's because we are simulating the educational systems in the higher education for all universities among the world. So in any university, no students can upload any certificate for the system. That to avoid any possibility for fraud or manipulation from the students' side. So the only issuers who are the responsible to issue and upload the document to ensure the originality and to prevent any possibility for fraud or manipulation.
Thank you so much, Dr. Bakri. And Thank you again for everyone who came today to this talk. And congratulations again, Dr. Bakri. We are so happy to have you back. And inshallah, we will meet soon and discuss about these interesting topics. Inshallah, there will be so many possibilities to work together, whether it's in a project-based work or whether it's a research direction. So thank you so much, Dr. Bakri. Again, we are looking forward to meeting you. And thank you so much, everyone, for coming. Inshallah.
Thank you very much. Just a last point. I would like to remind myself and you all, if anyone, if my presentation catches attention of anyone, and also if anyone would like to know what exactly, to have an idea about the future work that I'm currently working on, or the future work that I'm planning to work on. So please just double check my publications. In some publications, I already provide some details about the future work. Some of them already at rest, and some of them under working, and some of them are planned to be done in the future. So I'm very open for any collaborations. I'm very open for any ideas, and also I will be glad to have this work done by the team at all.
Inshallah, inshallah. And this talk will be, inshallah, uploaded in our college YouTube channel, so everyone can have a look at it again and see, as you said, the publication and all the things that you were talking about today. So thank you so much, Dr. Bakri. Thank you so much, everyone. We'll hopefully see you again, and I wish you a very, very happy day, inshallah.
Thank you very much. I wish the same for the all.
Thank you so much, Doctor.
Thank you.